Welcome to my channel. Google, IBM, and several other technology companies are competing to develop and perfect a computer that is more powerful than a supercomputer, namely a quantum computer. They believe that the future of supercomputers will shift to quantum computers that have incredibly high speeds. But, what exactly is a quantum computer? And what makes it different from a regular computer? I will begin the explanation with how a normal computer works. The smallest unit of computation in a normal computer is called a bit, which consists of two states: 0, commonly referred to as the wrong state, and 1, commonly referred to as the right state. The combination of these bits can then be scaled up to process large amounts of data simultaneously. And to process the data until we get the desired result, the processor uses a method called logic gate. Combination of logic gates, usually consisting of OR, and others, will determine the processing results. And to process this logic, they need transistors as switches that determine the logic flow. However, in performing a computation, transistors require electricity that generates heat due to resistance. To work around this, semiconductor companies such as AMD and Intel make their chipsets very small. Even now, AMD has successfully made chipsets as small as 7 nanometers. On the other hand, this will also become an obstacle. The smaller a chipset is, the more difficult it is to produce. In addition, the size of this chipset is already smaller than the HIV virus, which has a size of 120 nanometers. The problem is that as chipsets get smaller, it becomes easier for electrons to escape from the logic gate, which will then result in imprecise data or even data errors. This process is often referred to as quantum tunneling. This is where quantum computers take over. The basic method of processing is using quantum mechanics. Quantum mechanics is a basic branch of physics that replaces classical mechanics at the atomic and subatomic level. Systems that follow quantum mechanics can be in a quantum superposition of different states, unlike classical physics. This science provides the mathematical framework for various branches of physics and chemistry, including atomic physics, molecular physics, computational chemistry, quantum chemistry, particle physics, and nuclear physics. Quantum computers have a unit called qubits, which will also have two states, namely 1 and 0. But what sets them apart is that one qubit contains both 1 and 0, depending on how we look at it. This ability is often called superposition. In addition, qubits can also be seen in several dimensions, such as the rotation of magnetic force or a photon. So, we cannot predict whether a qubit is 1 or 0. However, users can determine the content of these qubits. For example, the direction of a photon from top to bottom or from left to right will produce 1 or 0. So, a photon can only be measured when we want it to be. The difference between bits and qubits is the processing power. If in 4 bits, only one of 16 probabilities can be obtained, 4 qubits have all 16 probabilities at once. In addition, qubits also have a special property called entanglement. This property can change the condition of one qubit with just one nearby. This allows users to predict the content of other qubits by measuring only one qubit. All of these things make quantum computers able to perform one task and get all probabilities at the same time. In addition, data processing performed by quantum computers is faster. On the other hand, a computer can only solve one probability at a time. The best use case for quantum computers is searching for something in a database. If a regular computer has to check probabilities one by one, a quantum computer can search for it in all places at once. Another example of the use of quantum computers is for use in IT security. Quantum computers will be able to generate a very secure encryption code, where a supercomputer can only decrypt it in hundreds of years. Finally, the field that will benefit the most from quantum computers is in research. Researchers, especially those working to simulate molecules, will be much more efficient. This is because this simulation process requires very large resources. This means that the faster a scientist solves a new protein simulation model, the greater the development in the field of medicine in the future. So, what is the impact of quantum computer technology on giant companies? Google claims to use quantum computers to create an algorithm for faster and more efficient machine learning processes, which will affect the abilities of their AI. The American search engine company claims that their 54-qubit Sycamore processor can solve a problem in 200 seconds, while the same problem would take 10,000 years to solve on the most advanced supercomputer. On the other hand, IBM's quantum computer, IBM Q, is currently offered for use in several fields, such as business, application development, research, and education. They even allow users to access it through the cloud. So, will quantum computers eventually fully replace current computers? For now, it seems unlikely. This is because quantum computers are still only being used for specific purposes and are not designed for household use. However, it is not impossible for quantum computers to become a common tool used by people worldwide in the future. Thanks for watching.